transcription. Okay. Thank you very much for being here. It's the third webinar for the internationalization pillar of UKRAS. And we can start immediately with our presentations while the audience is joining us. And we will start with Patricia Rosen from the Bauer Institute for Health and Safety in Germany. Thank you very much. She's also the chair for Human Factors in Robotics of the Technical Committee on Human Factors in Robotics of the International Economics Association. Thank you. The stage is yours.
Thank you very much, Jacinto. I will just... Can you see my slides in presentation mode?
Yes, we can.
Yeah.
Okay. Well, yes. Thank you very much, first of all, for having me. And today, because the topic was on robotics cobots in industrial manufacturing, I thought I will tell you something about OSH-related risks and opportunities and some findings we came up with in one of our projects we recently finished and did for the European Agency for Occupational Safety and Health, EU-OSHA. But just beforehand, I would quickly like to recap for those who are not familiar with Bauer, what we are. We are a federal research institution for the German Federal Ministry of Labor and Social Affairs. This means we do a lot of research and development, but our main goal is to give advice and to our ministry. But of course, we do also transfer and communicate all of our findings, and we have a strong focus in new and emerging technologies. And as I just said earlier, we did a very extensive project for EU-OSHA, where the idea was to find out what impact on occupational safety and health in terms of risks and opportunities do digitalization technologies such as advanced robotics and AI-based systems have. And for that purpose, we did, of course, a very extensive analysis of literature. We looked mostly at meta-analysis and systematic reviews. We also conducted some expert interviews, and we contacted the European focal points, which are institutes or organizations like Bauer all over Europe. And in the end, in the last phase of the project, we conducted 16 case studies where we talked to actual companies, small companies, but also larger companies who had already deployed either an advanced robotic system or some kind of AI-based system to automate some specific task. And we talked to worker representatives, to management, all different kind of stakeholders in the companies. And from this data, we developed these case studies. And we also had 3 case studies where we were dealing with collaborative robots or interactive robots, which were used for industrial manufacturing tasks. And so I thought it would be a good opportunity to just show you these 3 use cases and see what actual companies have reported, what they were struggling with or what their challenges were, but also what their benefits were. So in the first use case, we had a very classical advanced robot. This was a robotic system used in from an automotive industrial supplier. And here, the robotic system handed over a workpiece to a worker, and the worker could then do some inspection tasks. And after inspecting it, the worker took over the piece and put it somewhere packed the workpiece. And what was reported here is that some of the challenges the company reported that some workers did experience fear of job loss. So they really had the fear of being totally replaced by the robotic system. And they also said that they had the challenge of facing more task switches when operating the system. But on the other hand, the opportunities they outlined that they really had a decrease in physical strain, so less physical load. The workplace got healthier. And also some workers reported that they really had the feeling that they had experienced some kind of upskilling because they learned how to use the technology. And of course, that's a very achievable goal, that people experience their job more, that they gain more skills. In a second use case, this was found in the lumber production. And here was a large robotic system that sorted boards and looked out. So this was a robotic system that was also equipped with some AI-based system. And here the system looked out for defect boards and automatically sorted into defect and non-defective boards. While an operator was sitting behind a fenced, so the robotic system was in a fenced area. The operator was sitting behind this and was just taking a look at the results. And the opportunities, again, what we see here is similar to the other use case, is that people said they had a decrease in physical strain. And they also said they were removed from some environmental hazards, and that was something that was positive. But on the other hand, they said, well, they were still, and this is probably a little bit also, because we are in the lumber industry, and it's still a workplace where, big machinery is handling big parts. There still is the risk of a physical risk in case of malfunctioning. So this challenge kind of remains, although there has been partly some automation of the task. And then we have a third company here. This was a company from which served as an automotive supplier. Here, the robotic system was used for sewing bags, and this process beforehand has been done fully manual, and now it was supported by the robotic system. And here, again, when we are looking at challenges that were reported in this use case, here again, people said they had some negative attitudes toward the robotic system and were a little bit resistant at the beginning, whether this would be a good automation technology or not. And they also feared that people would, or they said that it is a risk that people will get de-skilled, so they will lose the skill of the actual sewing task. But at the same time, the company reported, when we're looking at the opportunities, they said we could use this kind of technology to provide more task rotation, so we have greater variability when performing a task, and of course getting familiar with the overall technology will then, on the other hand, lead, if it's done in a proper way, will not lead to de-skilling but rather to upskilling. So it really also depends on from which perspective you're looking at. And when we looked at all of the different use cases we have developed, we also tried to figure out what are key findings reported in most or reported with most companies. And what we could find is that they, and that's probably something that's not really new in human factors research, but I think the very interesting result is that this is something that really came from the companies themselves. They said early involvement of employees and the provision of training is really important, because this will help you to make people familiar with the system. It will help to decrease potential fears, which might be something the workforce is dealing with. Also having clear and very direct communication processes, not only at the beginning, but throughout the whole process, is also very important, because again, this really reduces potential fears and makes the whole change process very transparent. Also, looking a little bit back into what we already know about system design. So the consistent application of interaction design principles, which are, for example, written down in the ISO standard 9241, having this in mind when designing the specific system is also very helpful, and also considering health and safety aspects already early from the beginning on, and not once the system has been implemented and then kind of rearranging everything, but thinking this already from the start on is a very good idea. And then maybe just one last slide I would like to share. So based on this whole project we have done, and based on all the literature we have read and the use case we have developed, we have then in a follow-up project, we developed so EU OSHA provides these so-called UKRAS tools. It's an online risk assessment tool which helps companies to perform their risk assessment. And so we developed a specific tool which refers to the automation of tasks by advanced robotics or by AI-based systems. And it's designed, it has three main modules, where one is obligatory for everyone, and two are optional modules based on whether we are talking about the automation of a physical task or whether it's the automation of a cognitive task. Just to give you an idea what these kind of risks look like when we're, for example, talking about the automation of a physical task, we of course also have psychosocial aspects which should be considered. For example, there could be the risk of the loss of responsibility, or we have the risk that specific robotic design features do not match the application context. For example, if we're thinking about a system which is used in a very loud, noisy environment, but has some kind of voice interface. So these are all kind of things companies should take a look at, and with the help of this tool, they get a little bit of guidance on what could be potential risks when introducing a robotic system into their process or into their environment. Ooh. And this looks a bit funny. I had some, so if you, I can share the slides afterwards. There are some further information for further reading. And with that, thank you for your attention.
Amazing. Thank you very much, Patricia. Oh, sorry, Justin.
Yes.
I was gonna ask a couple of questions, and people feel free to ask questions as well, both on the chat or even from the other speakers. So that's good work that you've sort of done, sort of collected case studies, because I think sometimes we forget about sort of the impact that we have on the operators and the humans as well. So that's quite important to consider. So I've got a few questions. The first one is on. I'll start with the cobots. So you've mentioned that some of the sort of case studies covered cobots, the use of cobots. Now you probably are aware that in the latest ISO, I think it's the 10218 standard, the word cobot has been removed and it's collaborative application rather than collaborative robot. But what was the feeling of people? I don't know if you managed to collect this information, but did they feel a difference between the use of collaborative robots and industrial robots, or is there any? Did you manage to notice any difference there?
Well, first of all, I have to say I think this development is really good that they've changed this, because and I think this is also something that we always get also as a feedback from industry, real collaboration tasks, or if you have the definition of what is a collaborative task, what is a cooperative task, and what is a task where a human and a robot just coexist, you can see that real collaboration, which means you have one worker and one robot handling one work piece at the same time, you hardly ever see anywhere in industry. So you have And I would say if you give out this definition, industry is very aware of that, and they will say, okay, yes, we have, I mean, sometimes it's when you're talking about heavy lifting task or holding a heavy object. But I would say, because we were very open to find, we said we don't need especially a collaborative task. We were also very interested in the cooperative or coexisting tasks. So, and I didn't go into all of the details deeper, but when you look into the documents of the case studies, it's very precisely described that mostly it's not a collaborative task per se, but more a cooperative task. So yeah, and I think therefore it's also a good development that the standard has been updated, because I think it kind of used to be also giving kind of false expectations when you sell a product and saying, oh, it's a collaborative robot, and then everyone bought it, but they didn't have any collaborative tasks. So yeah.
I think the one thing that the cobots managed to solve is the sort of making programming a robot a bit more intuitive. But in terms of safety, I think they did really little to the safety of the collaboration task. So the other question was on there was quite a recurrent theme that there was a lot of negative attitude from the workers towards the robot. Do you think that's sort of justified? And why do you think is this lack of education on the matter, or is it actually just is real that some of those sort of skill tasks are gonna die? Which I think they're gonna die anyway, but I don't know. What's your opinion?
Well, I would say, I mean, I experienced it myself when I started researching the topic of robots, and I can still see it in our lab when we are having people who do not engage with robotic systems on a daily basis. I mean, it's a technology, I would say, that is very impressive and really triggers a lot of emotion. And also, I mean, just when we, if we have the spontaneous association, if I say to anyone, think about a robot, maybe a large number of people would think of some kind of Hollywood theme robotic system rather than the functional tool kind of system. So I think that's something we really have to be aware of, that these kind of mental schemes people have in their minds when they are talking about digitalization, robotic systems. I mean, most of them probably, once they have started working with these kind of systems, they will actually see that they are not going to take entire jobs, but they will support them in individual tasks. But people have to experience that themselves. And this is why, for example, the results we also came up with, that the company said, well, taking people in very early at the process really helps, because this reduces this. And I mean, it doesn't have, the fear probably is not really grounded in something, but we still have to take it serious, because, I mean, this is just a feeling, but a feeling can be very strong. It can be very, one colleague talks to the next one. This is also how, informal communication starts throughout a company. So it is a very powerful thing that could happen in a company. Therefore, I would say it's really a good point to pay attention, to take it serious and say, well, look at what the system is capable of doing or what not. So I think we always have to take the perspective of non-technicians, people who are not working with these kind of technologies on an everyday basis.
I think it's probably on us. We should, like, research centers like ourselves, we should probably go out there a bit more often and educate the people that even if they think they don't have any applications with the robotics, if we just introduce it to them so they can understand and have a sort of reduce that fear, maybe. Okay, and then last question before we move on is on that tool that you create for risk assessments. So is it my understanding that is it able to generate, if you sort of describe the task, is able to generate some sort of default or like an example of risk assessment that they can be used for the task? Is that correct?
Well, I mean, I would say, I mean, it's not like if you go through all the points that you're finished with your risk assessment. That's not the case, but it kind of will bring to you all the aspects, for example, also the standards and the some regulatory bodies. And of course, again, we are talking, this is on EU level, this is not on national level. You know, some specific regulation might apply. There is different regulation in the UK than in Germany, for example. So, but it will give you kind of, you know, it will trigger all the aspects where you might feel, oh, I should have a look into this topic. And also, I have to say, it might be a little bit overwhelming, especially if a small company goes through all this and says, oh my goodness, you know, there are so many points. But on the other hand, I would say, if it's done, you know, if you just think about it for 1 or 2 minutes, say, okay, is this really an issue? If you do that and then do a proper risk assessment, then it's really fine.
And is that open to be used to anyone? Anyone can have access?
Yeah. I mean, it's only available in English, and I know that that's also a little bit of a constraint. But if, for example, one country says, okay, we really want that in our language, they can just write to EU OSHA, and eventually they will translate if they say there is enough interest of one country, for example. So yeah, it's free to use for everyone.
That's really good. Yeah, cool. I'm done with my questions. I think unless anyone's got any more, we can move to the next speaker.
Yeah, thank you very much. And now it's time for Daniela Sawyer from the EMRC and the University of Sheffield. Daniela, the stage is yours.
Thank you. Hopefully everyone can hear me all right. Lovely. And I'll try to share my screen as well. So I'm just going to talk to you guys a bit. I'm going to try to full screen it, about the Advanced Manufacturing Research Center that I'm a part of and Gianmarco is a part of. Hopefully you can see me transition through the slides. If someone can just say yes, that would be great.
Yes.
Yeah, we can see that, yeah.
Lovely. Right, so as you already alluded, in a sense, the Advanced Manufacturing Research Center is actually a part of the University of Sheffield. It was kind of like a faculty, one of the schools at the university, really. However, we do things slightly differently here. First of all, we're not in the main campus, which is based in Sheffield, UK city centre. And you can see that it actually started back in 2001, and it was kind of a venture, a joint venture between a local businessman and a professor at the University of Sheffield. So that's the way we kept the ties very close to the university. But our first building was built in 2004, and it's encircled there. You can see the vast amount of space. There is a bit of history with this particular location, but it's more like at the national level rather than international level. There were some minor riots, etc., that happened in that location. But I think what I want to bring your attention to is to how much the space has changed. So it's the same picture. You see an arrow there. It's actually pointing to that initial building that was built back in 2004. And this is kind of how it looks like nowadays. I actually think the residential area is a little bit more built up. So the appearance of the Advanced Manufacturing Research Center signified a big growth era for the region. And we also attracted other companies to come there due to the research that we were doing. So you can see that Rolls-Royce has a branch there now, British Steel, Nikon, and even McLaren that we housed for a period of time. So the way the AMRC expanded was starting off with our first partner. And our first partner was Boeing. And due to that, Boeing also opened a factory very close to us that we actually participated in opening. But since then, we grew into partnerships with multiple companies across different sectors. This building that I'm showing you in this picture, again, this picture is actually outdated because the university started opening more and more buildings around it. But the circular building that I'm showing you in this picture is what I'm actually giving this presentation from right now. That's Factory 2050. And that's the one I'm going to talk to you more about. As if that wasn't enough, we actually expanded into Wales. So now we have AMRC Wales that we opened up in 2019. It's closer to Airbus. We actually are sharing a building with Airbus there. And we also have a location in Northwest that was opened in 2022, just to be a little bit closer to BAE Systems. Both of these companies are strategic for our research. The way we work, it's kind of a hybrid. I normally like to call it between academia and industry. We aim to act like a bridge. So in academia, you normally get things from TRL 1 to 2, maybe 3, and we tend to take it from TRL 3 to 6, 7, if we have the capabilities to do that. The way we get funded is basically a thirds model. So a third of our funding comes from the government via the Catapult network. And if you're more interested into the Catapult network, if you've heard about the Catapult network, I'm more than happy to talk to you separately more about that. We also secure our own funding through income generation via grants. So we normally go for your usual suspects in terms of the UK. So we have the Innovate UK, UKRAS, EPSRC, or the ATI. We do go for international funding as well, especially now that we've been allowed back into Horizon. We have quite a few engagements with Horizon Europe, but we also work closer with partners, as in industrial partners. If they want us to do a particular piece of research, they can come with a purchase order to us, and that information stays protected only to them. It normally works under non-disclosure agreements. In terms of our partners, like I said, when we started off only with Boeing, and now, sorry, the slides have some transitions to them. And now we've grown to something around 120 partners. We have 2 tiers. That's why you see the line in the screen. So we have a tier 1 partnership and tier 2. Tier 1 offers a few, well, a higher contribution really, money-wise. The tier 2 partnership, it's less, and it's also in kind in terms of training. It could be equipment, etc. So we're quite, or at some point we were quite unique in the way we were doing the partnership. You know, not many companies would have Airbus and Boeing around the same table, but we somehow managed to do that. Again, because I'm part of the Factory 2050, I will be speaking more about that. As you can see, this is a slightly newer picture because we have 1 extra building in there. So Factory 2050 is home to the Integrated Manufacturing Group, and kind of sits in the name. What we do here is a lot of automation. We have 3 main buildings. This is Mark 1. And then it gives you some information about what we have, and I can share the slides afterwards to kind of understand the space and what we can do in here. We have Mark 2, which is a 100 meters long building. So we have a lot of space. We do research there with Rolls-Royce SMR, for example. And now we have also Mark 3, which is kind of like an automation and composites building. That one is 89.9 meters long. So it's a very big building that has a lot of automation equipment inside of it. We have some of the largest robots in the world, and they're going to be handling plies of composite material. So in terms of what we kind of do at the Integrated Manufacturing Group, we do a lot of advanced automation. We cover smart supply chains, smart factories, and in the picture there, you can see our newest facility. We look at through life engineering, but in the background, if you like, on the other side, we look at data quite seriously. So we invest a lot into the data ontology side of things, the data architecture. We have an entire team dedicated to data science and data integrity, which is all about the cybersecurity of your data and your assets, but more from an OT perspective. That is split into 4 main areas that we work in terms of the integrated manufacturing group. So you have the digital and the data systems. So around that, we do a lot of computer vision, digital flow, you probably heard about condition-based monitoring and predictive maintenance, a little bit of structural health monitoring, but more around the in-process monitoring. We have an entire team dedicated to that. And then we have the automation and assembly, which work most of the time hand in hand. And we look into design for X, so it could be design for assembly, disassembly design for automation, etc. We had quite a few success projects in automated disassembly, modularization. We look at collaborative systems and equipment manufacturing and fixturing. And one of the topics that I personally look into is automated determinant assembly. And then we also do a lot around electrification. We have capabilities to do spin testing, non-conventional coil winding and shaping, albeit I'm not the best person to talk about electrification. We have a senior tech fellow that takes care of this area. But yeah, we do a lot with rotors, laser processing, etc. And we have the manufacturing intelligence side that looks more at your factory level. It does layout optimization, discrete simulation, manufacturing flow optimization, and they do a lot of work into the supply chain modeling and cost modeling. And all of it with the idea that it's going to help decision making. And then towards the end, I just wanted to put together a few projects that we work on. They're going to be more towards the automation side of things, because that's the area that I represent. This was actually an ATI funded project, so it was a grant funded project. It was called Delta. Our lead partners were Airbus UK, but we were working under Spirit Aerosystem. And the task here was to develop a low cost and quite compact end effector, which we did. And we also did the factory acceptance test and the site acceptance test for Spirit Aerosystems. In the picture, you can actually see it deployed at their site and on their shop floor. That's a big robot, and you can kind of understand what it's doing there. It's fastening. It's doing fastening with temporary fasteners. What you can't see clearly is that it has a lot of cameras in it installed, and lasers to help gather in-process data as the fastening is happening, about the quality of the fastening, if it's snapped all right or not, etc. The point of it was to utilize all this data in the decision-making process. This is yet another project that we did with Airbus UK as a lead. This is the clean and seal machine. So we basically not only built the entire machine, yes, we bought the AGV that you see in the picture separately and the robotic arm separately, but we put it all together and we integrated it. And it's used to do exactly that on spars and ribs assemblies to clean and apply sealant. This machine has been UKCA marked. Not something that we usually do, but we can support in if our partner requires it. We have 4 patents that have been granted on this and 1 patent that is pending. It has been presented on international platforms like SAE Aerotech, and is currently deployed on their shop floor, again with our support. So we work very closely, not only once we develop a solution, we also help with the implementation of it. This is an older project, but nonetheless very important. This is a robotic countersinking cell. It was done with BAE Systems, and we have some links there to a lot of media coverage that we had and prizes that it won. We managed to, it's in the name, it's a countersinking. One of the robots dictates the motion of the other. So we did an integration between the 2 robots, and they had a panel. One of them had a vacuum and extraction system, and the robot with the bigger end effector had a drilling head. And again, lots of vision and camera lasers for normalization. For this one, the highlights are that the cycle time has been reduced from 60 to 20 seconds. It offered a lot of operating savings to BAE Systems. It won a few awards, and it has been actually industrially deployed since 2016. And what I mean by that, it's reached TRL 9s on the shop floor. And again, a very similar situation with the smart workstation. You see them around a lot right now, and you see them around at trade shows. But we worked on some of the first few smart workstations, and the funding was via BAE Systems. And this particular one, again, won the Leader Award, and it is industrially deployed at the site of BAE Systems in Wharton. So these projects are just a few of the ones that we've worked on and have been successful. They're not all of them, as it were, but it's the only ones that I have time to include in the presentation. We have a link to case studies that you can go and explore yourself as well, if you so choose, of a lot of different projects that the MRC has done. Yeah, that's about it. Thank you.
Thank you very much. I have just one question, because we need to have time also for the final ones, the final round of questions. Thank you very much for your presentation. It was really impressive, and it's impressive to see how big is the variety of the partners of the MRC and the types of applications. And the interest for data-intensive applications and all this attention for the data infrastructure is quite peculiar, in my opinion, because probably the effort for the interoperability, for achieving a good interoperability, would be quite, especially using solutions to different partners. How big is it?
Yes, it is, but I think this is where we are. So we have, first of all, interoperability is an area that we work a lot in. We also developed our own connectivity framework. So that helps a lot. Rather than make things bespoke, we're trying to push our own unified namespace through the work that my colleague Alex Godby here is doing. And we're also, the research that we're doing on the data ontologies, it's all about changing the standards about how all of our industry works, and everything is so bespoke to each individual partner. Now, surprisingly so, maybe we had quite a bit of success, especially with Factory Plus, which is the open framework of the connectivity of extracting all of this data. And it's requiring, I'm going to make it sound very simple, and I feel bad for all the work that goes into it, but it just requires a gateway that you put next to your cell. And it doesn't matter what control system you have and what operating system you have. So it doesn't matter if it's a KUKA robot, for example, or an ABB robot. It doesn't care. It extracts the information. It presents it back to the user in a usable physical format, right?
Especially considering that you need to approach as much as you can the real time more than what is happening in an academic center, for sure, because you need to be really close to the actual usage of technology. Thank you very much.
Yeah.
I know, and I'm more and more curious to see the center of the MRC. If someone will invite me, I will be happy to visit it. Anyway,
consider this an invitation.
Thank you very much, and you're welcome, every one of you, to visit Bristol, the Bristol Robotics Laboratory, whenever you want. Thank you very much, Daniela. And now it's time for Ilya Jovanovic to talk about the works of Taiga Robotics and Canadian Robotics Council. Thank you very much.
Thank you. Let's see if I can share my screen. Okay, can you see this?
Yes, we can, yeah.
Thank you, Jacinto. Yeah, I thought I'd take this a little bit differently. Something that's been coming up in a lot of my conversations. So myself, I'm an entrepreneur. I started my own company out of grad school doing robotics. I'm also the co-chair of the industry committee at the Canadian Robotics Council. And something that's been coming up a lot has been humanoid robots and how they're going to transform the automation landscape. I get this from the customers I talk to. We get a lot of these conversations at the CRC, and I thought I'd share some of this stuff with you guys today because I find it very interesting. A little bit about the work I do. So the Canadian Robotics Council our primary mission is to unite the Canadian robotics ecosystem. And in doing so, we're hoping to also increase the adoption of robotics in Canadian businesses. We have a lot more small and medium-sized businesses, ratiometrically, and they have historically been not the biggest uptakers of automation, and they tend to use people a lot more because they rely on that, and I'll get into a bit more of that. And then my company, Taiga, we do advanced robotics control for all kinds of applications. We've done everything from deploying the first robotic arm into a Canadian nuclear reactor building to sorting trading cards at a comic book store. And right now we're working on a technology where we can take a cell phone video and turn it into a robot program for people that are not experts at robotic programming and don't want to involve that kind of expertise. But what I want to talk about is humanoids, how they're going to affect this landscape, the robotics landscape, and specifically from an industrial perspective. So I'm not really going to consider their viability. For all intents and purposes, I think assuming that they can deliver on their promises is fair. It's just, will this displace robotic arms? And will this displace a lot of the automation capabilities that we've already built up? And I want to look at it from two perspectives, the small business and the large business. There was an interesting article recently that came out of the Telegraph. I don't know if you guys saw it, but Ford's CEO and Andrew Forrest from Australia, he's a mining tycoon out there. They were interviewed about their recent trips to China. And one of the quotes there from Andrew was, and we're just going to read it, and you're walking alongside this conveyor, and after 800, 900 meters, a truck drives out, and there are no people. Everything is robotic. And there's a picture of that assembly line on the left. And to me, this is sort of an indication that, do you really need humanoids in a situation like automotive assembly or production, where we've been able to basically remove people from it? Is there anything special about the human form factor in a setting like this? And I think as we see more and more automation come through, the answer is going to be no. And then the other side of like what a big business could look like is a fulfillment center. And there's been this growing trend to make these spaces also not very human compatible. So you have systems like Ocado's OSRS and AutoStore's ASRS system, where it's not meant for people at all. So a form factor of a human doesn't really carry any benefit here. But this is kind of obvious. The more interesting thing is with small businesses. And in my work at Taiga, we talk to a lot of small businesses, and they use a lot of people. And this is kind of where I think most people are worried and think that humanoids are going to come and replace a lot of this, and also displace the opportunities for more conventional automation when they do so. So humanoids are going to be good for small businesses, right? Well, the question I want to ask is, why don't they have robots already? And when I ask people this question, usually the answer I get is it costs too much for small businesses. But I don't think that cost is really the root cause of their apprehension. I think something underpins their apprehension to spend money. And what they say is, oh, I don't want to spend that money. What they really mean is, I'm worried spending that money. And I say that because a lot of these businesses have millions of dollars of capital equipment that they've already purchased, and tens of thousands of dollars for robotic arms to assist with some of this isn't what's holding it. Like, the cost of that isn't what's holding them back from adopting robotics. And certainly when you look at how much they spend on labor right now, the economics make sense. What tends to really drive their apprehension to buy or adopt robotics, I should say, is the lack of flexibility. And it's flexibility in two ways. It's flexibility of the space they use, and it's flexibility in the function. So first, talking about the space, organizing a space is incredibly difficult for a factory. You need to think about how stuff flows through there, and small businesses are constantly pivoting, and they need to be more agile and change what they do and change what they offer, because they can't compete on scale like larger businesses. And when you look at a typical assembly line, like there's one right there, you can find marketing for this type of stuff everywhere. It increases a lot of complexity in terms of how this traffic flows. The example down there, for instance, if you had a smaller footprint facility, that could bisect your facility. And then how do you get materials or people from one side to the other? And does that create choke points? And does it even allow you to move equipment in and out? Sometimes things break. Sometimes things need to be replaced or upgraded. And all this needs to be considered. Certainly in this capacity, humanoid robots, because their ability to move around and their smaller footprint would help. But is it their form, or is it their adaptability that you can move them and bring them back to a spot and then they can keep working? And then the other part is task flexibility. And this is a picture from an application that we recently did at a brewery. And I think that the task determines the form factor. For instance, these are 12 kilogram cases of beer. The workers that used to do this job would do this for 8 to 10 hours a day. I had to do this for a little bit while we were helping set up the robot. I would not want to do this for more than an hour. In fact, even an hour was too much. What really drives them is that they need to be flexible. They're small. They constantly need to offer new products. They don't have some staple that they can just mass produce. So for them, the task the robot's performing needs to be flexible, and how the robot uses the space and the environment needs to be very flexible. And this, if they can't get it, directly eats into their competitive advantage. So what we are seeing when we look at humanoids is that a lot of the companies that are building humanoids are switching to spaces that are inherently human focused. So a lot of humanoid companies now are shifting towards marketing to home assistance. And I think hospitality is also going to be another really big space for them, because these are places that we fundamentally designed for people. And in that capacity, the form factor does offer unique benefits. So what it might sound like I'm getting at is it's just the AI in these humanoids, and we can stick this onto a conventional robotic system and we can gain all these benefits. I think it gets a little bit more complicated than that. One thing that I've learned working in this field is that automation tends to be very simple to describe. What you want it to do can be easily articulated and explained. But if you remember the movie Iron Man with the icing problem, there are unintuitive and often hard to foresee challenges that arise once you get into it. And this is the crux of automation. And I don't know that necessarily an AI is the sort of creative ideation machine that can anticipate those problems and work through them without the same process that people do. The other thing I want to point out is that existing automation is rich with capability. And one of the biggest problems, I think, is usability. The robotic arms that can lift 20 kilograms, that's far more than a person can do for a full shift. And it's really, how do we make those machines more usable for the smaller businesses and the people that lack automation right now? The other thing is, I think AI, at least how we've used it, it's most powerful when it's lowering the bar to be an expert. A great example of this is vibe coding, where now pretty much anyone can write software, even if they've never done it before, with the help of an AI, simply by describing what they want. And I think the automation ecosystem should be looking to move in that same direction. Thank you.
Thank you very much.
Thank you. Yeah, that was really good. Yeah. I've got a couple of questions, but I might start open the sort of with the first question. I might open the panel discussion just because we've got less than 10 minutes left. So my question is that the main reason why the UKRAS started this sort of series of webinar is that we want to sort of improve links between researchers sort of outside just the UK, and we want to look at other centres. So Canada is one of the areas of interest because both, I'm assuming, for Germany as well, and then the UK, because with recent, let's just say, geopolitical development in the world, there's a more of an interest to sort of collaborate more with Canada compared to other sort of nearby areas, let's say. So how would you sort of, is that something that you see, especially with the council that you're part of, how can that happen? Is it easy, do you think? What would you need to collaborate with researchers from the UK or Germany? And then I would ask the same thing to Patricia, like, is that something that you've experienced? Have you worked with Canadian partners in the past, and would you like to do more? How can that be done? But let Ilya speak first, and then you can go next, Patricia.
So we have a bunch of research labs, and I feel like the answer is going to be the same in most places, but it's connect with the research labs first, because they have the broader networks. The Canadian manufacturing ecosystem there's a lot of small businesses. It's quite fragmented in that way. So you need centralized places. The Canadian Robotics Council is trying to be one of those type of entities where you can connect with us, and we can connect you with the different partners and different people with robotics capabilities within Canada. And then they also can foster those connections to end users and other people that might want to try out this equipment, try out this automation, or help develop it in a real setting.
And in terms of practical collaborations, like, have you done that with any European partners? How easy it is? Because I know Horizon now includes Canada, so that would be one example. But Horizon is extremely competitive, because obviously, apart from the actual collaboration and meeting people, we need to put sort of a money where mouth says, or I don't know, like, so we need to find the actual way of funding these things. Are you aware of any grants or anything similar that can support collaboration with European researchers with Canada?
I'll have to get back to you on that one. Most of the ones that we work with are intended for Canadian businesses. So I know in the defense sector, especially like DAN or something like that, that's a European, that is somewhere where European and Canadian companies can collaborate. But that's not just for automation and robotics. It tends to be more competitive because of its broader scope.
Yeah, maybe it's something that we realize we need to work on, and maybe there's something missing there. And then collaborative, we need to have this effort between Europe and Canada to sort of find a better way to collaborate. And then, Patricia, I can see you're nodding. I don't know what's your idea from a Germany perspective.
But I would say it's similar. I mean, first of all, our interest is always there, especially to work together with the technology developers, because we ourselves do not develop any technology, but we always take a look at the human factors perspective, so the end user. And Ilya, what you pointed out, I think that was really interesting, saying we are lacking some kind of usability. I mean, this is always what we also are constantly working on, saying how can we make interaction fluently, intuitive, all these kind of things. But the same as you said, Gianmarco, I mean, of course, I mean, we participate in Horizon Europe calls all the time, and it's very time consuming, it's very work intensive, and the turnout currently is not very good. I mean, I think we all know that. Nevertheless, I would say it's a very good opportunity. Once you get in there, I think it's one of the best opportunities, not also only research-wise, but I think also for researchers and industry to connect, to get into exchange. I would say it's still worth trying if we kind of make, can make up the resources. and yeah, just partner with people who have some experience in writing proposals. I mean, I can only say for our part, I would say we are quite experienced, and we will jump on any proposal. But if there is any other possibility, I know for Germany that in the past there have been special funds from our national research ministry, for example, for Germany and South Korea. So we have had like special fundings for specific pairings of countries. I'm not aware if there's anything comparable for Canada or UK. But yeah, I would encourage if someone comes up with anything.
Yeah, there is. I think for us, it's Innovate that normally does that from the UK perspective, and I've seen enough of calls for collaborations between Canada and the UK, for example, or UK and Germany. So that's where we normally go for that type of collaboration.
One thing that the UKRAS network started doing, and we only done one first round, and we're trying to do a bit more maybe the next round. We try to do a secondment scheme where we support or we fund individuals to go abroad to any company and sort of work alongside that company for 1 to 3 months. So that's another thing that I think would foster this collaboration, because we've got someone that's been there, spend the time. And speaking of human factors, having a presence in there, like making, those friendships apart from just working with people, just being in contact with people, that should help making that sort of creating that bridge for researchers to go through. And speaking to like sort of UKRAS events, what we're trying to sort of experiment with, and that's why I'm going to ask for your opinion on this. We're going to try and leverage all the international conferences that already exist, like uk-ras, IROS, or whatever. We want to sort of create almost like speed dating events, but for researchers, where we can have like, I don't know, 2 minutes or 3 minutes when people can just like, and especially for mid to early career researchers. So we want to sort of connect the future leaders of robotics in this company. So we haven't done it yet. We're just sort of trying to understand the sort of the logistics of it. But is that something that you think would work? Is that something that we should pursue, or is it something that's a bit of a waste of time? I don't know. We're trying to understand if that's something feasible or usable.
I can say that at those events, the Canadian Robotics Council has been making an effort to organize a Canadian, basically we would organize an after event for at least one of the days. That could be something that can be grown to be a slightly more targeted, like cross-country collaboration group to meet up after the event.
Okay, yeah, that's good to know.
Because it sounds like we need more of this, is what I'm hearing.
Exactly, yeah. Any other comments on that? I think we've got a question. I'm assuming last question, given the time. We've got something from the chat, so I can just read it out. If cost isn't the real issue, and I think that's for you, Ilya. If cost isn't a real issue for adoption in small businesses, but the apprehension of actually spending the cost on robotics automation, how do we overcome that challenge?
Yeah, so for the brewery, for instance, we used an AI, and I'm saying that loosely because part of it's a neural network, part of it is just things that use a lot of computation, to basically be able to reprogram the robot on the fly. So this brewery needs their end of line. That space is precious to them. It's where their production is, where their supplies go in, and it's where all the products come out. We overcame that by making it so that they can wheel this robot into a corner when they need to reclaim that space, and then set up the conveyor and the robot in the morning in about 5 minutes, reprogram it for whatever the new configuration happens to be, because it'll change every single time, and they can now use robotics. Whereas if it was a more conventional setup that was bolted into the ground, even if it was collaborative in the sense that you didn't have to fence it off, that would still be a prohibitive use of that space.
Perfect. Thank you. And I think the last question, which is for all speakers, but I'm going to ask it just to Daniela and Patricia, again from the chat, is in what ways has AI and digital automation affected the work that you guys are doing? If you can just do it in one sentence, because we're over time already. And not Patricia, if you want to answer first.
You mean the work me doing as a researcher, or my research topic, robotics?
That's all the question says. I'm not sure. Let's say, I don't know, either, both. I don't know. You choose.
Because I would say personally, of course, I think, I mean, I think we all experience how digitalization technologies changes our daily tasks and parts where we have been, or parts we've been doing, like writing, is easily supported by an AI-based system. But I would say regarding robotics, I have the feeling, especially for human factors, it's a chance that we can actually reach that area where robotics get more fluent, more intuitive, because some of the basic functions where humans would expect robotics are, for example, capable to grip, to navigate very easily, which from a technical perspective, they sometimes can't, but this will help to make the interaction more fluent.
Okay, thank you. Daniela?
In terms of what we do as an organization on operational level with AI, we're still going back and forth in terms of using AI, using it for grant application, not using it. You know, it's a tricky one, this one, as from an operational standpoint. In terms of research, we do research a lot into AI, and I personally, with my team, do research into robotics and AI. On a personal level, I use it whenever I can. I'm probably using it even without realizing.
Perfect. Okay. Thank you very much. I think we can end this webinar here. All the recordings are going to be available, including the other two webinars, very soon on our UKRAS website that we're going to launch in a month or so. Follow us on the usual social media to sort of get an update on that. And I think, Jacinto, I don't know if you want to thank the guests and then close the webinar.
Yeah, and anyway, we are late by 3 minutes, so I think it's better we wrap up immediately. Thank you very much. I have many other questions that probably it's better I share with you via email, especially on workforce training as the main barrier apparently for the adoption of robotics, and how to overcome these issues together, UK and abroad, in Canada and Germany, and together again. Thank you very much, and let's wait for the fourth webinar in our series, UKRAS for the internationalization. We don't know yet the topic, but we are quite happy about the robotics for industrial manufacturing as a topic of today. Thank you very much for joining us.
Thank
Bye.
you. Bye.
Thank you.
Thank you. Bye-bye.